try to sort of clean up some of the loose ends on this, but I'm really impressed with what you're doing. A lot of you have right answers, or you're just about there, which is great. I'm still going to finish this number one, although a lot of you did it. Like I said, listen if you need to, but if you multiply the first row by the second column, you get negative 3y and plus 0, so that's nice, and that equals negative 21. So that's why y equals 7. And then if I want to solve for x, I probably should be circling this second row, but I can honestly circle anything I want over here. I'm going to circle the last column just so I can show you guys that that would have to equal 24 since that's in the second row, last column. So 5 goes with 6. That means you get 30. X goes with negative 2. So I get negative 2x, and that equals 24. Okay, now again, if I'm doing something, you're like, how'd you get that? I'll point more, just ask. Obviously, solving this means x equals 3. When multiplying, you can circle any row and column you want, as long as it involves the variables that you're looking for. I'm going to skip down to this last one because, well, as you guys probably realized, it's also a little bit on the easier side. We said yesterday if an inverse is undefined, that's just code for the determinant is equal to 0, just like the homework problem. So all you got to do is really think about the determinant. You don't have to get too fancy here with thinking about inverses, but make sure you remember the determinant is to multiply the diagonals, in the primary first, the secondary next, but you always subtract. Make sure that you get that subtraction sign in there and say that it's going to equal 0. So we got a lot of negatives in this problem. I was just trying to make sure you guys were brushed up and being careful about all these negatives. It's negative 14 plus 3x equals 0. Yes, the answer comes out as a little fraction or decimal, okay, because if I add 14 over to the other side, I have no choice but to divide by 3 to get 14 thirds. Is there anything with this third problem? Okay, so number 2, it was meant to engage you quite a bit more. What do we have here? We basically have this statement that A inverse is equal to B. What that means is the inverse of A, which I need to find, is somehow going to equal B, which I'm already given. So as many of you did, you would start to find the inverse. Now the inverse is this, I don't want to say complicated rule, but it's got 2 parts to it. The first part of the inverse rule is to do 1 over the determinant. The determinant is when you take the diagonals and multiply them, and of course then subtract. So 4x and 3x when subtracted, yep, you get a determinant of x. So 1 over x, which I saw a lot of you find. Nice job. The second part of the rule is to do a little switching. And maybe you look back at your notes, you switch the position of those numbers, you make the other ones opposites. Now I'm going to recommend that, because you should do this for every problem, that you realize that this fraction out front is supposed to distribute into this matrix to basically make a final answer. So I'm going to recommend that we do that before we do kind of the step that involves the letter B. Are you with me here? I'm going to continue to simplify this. That just means everything's going to get divided by x. Okay, it's getting a little fancy here, but 4 over x, negative 3 over x. Now negative x over x is just negative 1, and x over x is just 1. So that's kind of nice for the bottom. Do you understand that this matrix right here is the inverse? It's the inverse. It's like the final simplified inverse. It says that the inverse is supposed to equal B. It says that this thing I just found is supposed to equal B, the matrix, the second matrix that was given. So what I'm doing right now is just kind of copying down matrix B. This is the crux of the problem, where we realize that these 2 matrices right here are equal. They're equal. And look, you know, there's parts of them that are already equal, but it's the x parts that we want to use to find x. Now, let me see here. Let me get rid of some of the extra stuff. That means that 4 over x would have to equal x. 4 over x would have to equal x. Some people would just look at that mentally and they would say, x equals 2. Okay, so you kind of just look at it mentally. That's fine. There's nothing wrong with that. X equals 2, by the way, happens to be the final answer. But I don't want us to just kind of get lucky. So let's use the other one. Now, the other one is that negative 3 over x equals negative 1.5. Once again, maybe now that you know that the answer is 2, you can look at that and say 2. But how do you find that answer using algebra? Whenever there's an x in the denominator of a fraction, you want to multiply that to the other side. This would be kind of like solving it with algebra. And now I have negative 1.5 times x, so that I can divide both sides by negative 1.5. If you're looking for the algebra, it would be negative 3 divided by negative 1.5. And again, you could pop that in a calculator if you want, but it does come out to be 2. Now, I'm not going to sit here and say, hey, are you ready to do a whole bunch of those? I mean, that's a harder problem. That's about as hard as it'll get, but I'm trying to get you to take what you learned and adapt it to problems that involve x. This is a little bit of a higher level class, so you're going to see some questions like this on a larger assignment that I'm going to give you. Before I give that to you, though, I want to show you something about how Desmos can do matrices. Okay, now just so you know, this isn't just kind of like a little fluff and stuff. This is actually a skill I want you to have. And I've never met a student that's like, I don't want to do this. Like once I showed you, you're like, oh, cool. Okay, so this is pretty nifty. You're probably going to want to do this on a computer, although it could work on a phone, but because of the typing that's involved, most students prefer the keyboard. If you flip the paper over, you can see where I'm suggesting that you go. It's desmos.com, but this time backslash matrix. Backslash matrix. How are we doing? Desmos.com backslash matrix. It might be something that you bookmark, or I'm sure next time you type it in and put that backslash M, it'll probably pull it up right away. So this is kind of like another, whatever you want to say, another app, another application of Desmos that basically lets you do matrix stuff. And so I'm not going to take too long for you to understand how it works. What I'm going to do is type in some of these matrices. So I click New Matrix, and it does a lot of things by default. It assumes that a student wants to type in matrix A. As you can see at the top of your paper, matrix A has a 5, a 7. I said that backwards, a 7, a 5, a 3, and a 2. I am using the tab button because tabbing kind of allows you to go from entry to entry. I'd be careful about using the enter key, because the enter key, if you do type it now, or if you had already typed it, it actually takes you to like another entry. It takes you to like another line. Now, by the way, I'm typing in matrix A and I'm typing in matrix B. I'm going to type in matrix B because I want to do some stuff with A and B. Notice that matrix B is a 2 by 3. So you have to use the little edit matrix plus minus buttons to make matrix B a little bit bigger. How are we doing? You want to use the matrix button?
Yeah.
Have you found it?
Yeah.
Oh, good. And you go over to edit to do a lot of the entries. Yeah. Good. Okay, now some of this is, I'm not going to hold you back, but we're going to do a few things like question 1, it says multiply A times B. Obviously, you could do this on your own, like without Desmos, but you could also tell Desmos to multiply A and B. I'm trying to hit the enter button so I can get to a new line. And then in this line, I can tell it to do whatever I want. Now, matrix A, I have to use like the symbol for matrix A, and then times matrix B. I don't really need to put a times sign there, because if I just put AB, it'll multiply. But I can put the times sign. You have to kind of use the little keypad that they have. And bingo, out pops the 6 answers. Obviously, it does it very quickly. So that's A times B. I don't know if you need to write that down. You just need to make sure you can do it. I'm on to question 2. Question 2 is to do B times A. Are you guys getting used to the idea that you just have to hit enter? If you hit enter, you get to a new line. Now, if I do B times A, I get sort of Desmos's version of an error. And if I actually hover over the error, it says that you can't multiply these because the dimensions are not compatible. That's because the numbers don't match up like we talked about the first day. No problem. I just wanted you to see how Desmos gives an error. Now, question 3 on my little half sheet says to do 2a minus c. If I'm going to do 2a minus c, I need to type in matrix C. Maybe you guys already did type in matrix C, but I kind of wanted you to see that you can type this stuff in whenever you want. I can type matrix C in, and then I can proceed to do 2a minus c. Make sure you use the keypad. Desmos needs those symbols. You can't just use your keyboard and type A. You have to use the little keypad on the computer screen. Okay, so the computer can do anything that we learned to do, and obviously can do it pretty quickly. I'm on to number 4, which is the determinant of A. Now, maybe you've already clicked it and typed it, but if you look at matrix A, the determinant should be a nice little 14 minus 15, right? I mean, that would be an easy problem on a test. You just take 14 minus 15 for matrix A. But I can use the determinant command, which is at the bottom of the little keypad here, and I can do the DET of A. Again, I can use the little command here, and out pops -1, not a surprise. And then I can also do the inverse of A. The one thing I want you to realize here is that I still have to type A, or I should say click A, and then I can hit the inverse button, which is down below. You have to click A and then click the inverse of A. Okay, and then it does the whole inverse rule. It does the switcheroo, and it does the 1 over the determinant and puts it all together in one flash. Now, I have to admit, I get nervous sometimes when kids are quiet. Are we okay? Is there anything I've done up here that you're like, I can't get it? Are you understanding how to kind of use the matrix feature? It's okay. It's nice. One comment, it's not going to be able to solve the problems that you did a few minutes ago that involve X and Y. You can't put an X and Y in there and Desmos solve it for you. But it can help you do some problems that involve big numbers, or like my fun fact down here says, It can help us to do a larger matrix. Now, look at the fun fact. I don't want you to misread that. That's not just, again, just bonus. It's actually something I'm going to have you do on this assignment, but you should say in a few minutes it's pretty easy to do. Fun fact, it says a 3x3 determinant can be used to find the area of a triangle. Go figure, the area of a triangle can be found with a matrix. Now, the way that you do it is by taking the 3 vertices of your triangle. Now, don't get lost in the notation. The vertices are just x and y's. So you take the 3 vertices of your triangle and you insert them into a 3x3 matrix. Okay, look at the little formula down there. I mean, you can write it down if you want, or just save this little half sheet of paper. I will give it to you if you ever need it. But the formula says that you're going to do 1/2 of, and then you fill the numbers into the matrix. Notice that the first x and y goes in the first row, and then there's a number 1, and then the next x and y goes in the next row, and then the last x and y goes in the third row. And then there's always a 1 that ends up beside, that ends up in the last column. Now, sometimes a student will ask, does it matter what order I put them in? The answer is it does not. And if you're a little bit unsure about what's going on, just relax, because I'll show you with this example 6 how we can find the area of that triangle. That's part of the formula, because what ends up happening is your determinant ends up being this big, and then you cut it in half. Okay, let's try number 6. Take a look. Trying to show you that there's parts of the formula that are kind of like always. So it's always going to be 1/2. There's a plus or minus in front of that, because if my answer would come out negative, I would just zap it with a minus, and then it would become positive. Okay, so these are the things that are always true about this formula. Now, it doesn't matter which point you look at and think is the first point. I don't know, which one did you think was the first point? I saw the 2 and 5, so I'm going to put that down as x1 and then y1. I'm pausing because you don't need my permission to keep going. If you want to fill in the other points, whether you're doing it on paper or doing it on your computer. By the way, if you wrote those last 2 rows the opposite way, you're fine. Leave it alone. You can actually put those numbers in any order you want. It's just got to be x then y, x then y. Now, the reason I just showed you this Desmos thing is so you can make easy work of that determinant. Otherwise, you would have to do an expansion by minors. And most students aren't jumping at the gun to do that. Just by the way, if your matrix screen you feel like is kind of like full of stuff, you can always hit the refresh button and basically it'll clear out. There's also a clear button down here, I see. But basically, I don't want to have all that other stuff in there. I just want kind of a fresh matrix so I can type in, 2, 5, 1, 6, 2, 1, and -2, -1, 1. So we can do the determinant of A, almost too easy. I can do the determinant of A. I get -36. And although Desmos will do it for you, let's make sure we understand that now we're going to do 1/2 of -36. Technically, we're going to do -1/2 of -36 because area is always positive. Sometimes it seems like a lot of work the first time, but you basically put these numbers into a matrix, do the determinant, and you get the area of a triangle. Pretty nifty. Listen, the final answer is 18. 18 units squared. But you want to do 1/2 of negative 36.
Mine just showed it up as positive.
Uh-oh, yours popped up as positive. I was hoping somebody would say that. You're fine. That's exactly what happens. I bet you put your numbers in the other way. Okay, so it doesn't matter which way you put them in. It's pretty cool. It's still going to come out to be, quote, 36. Okay, whether it's negative or positive. Okay, so a couple different things happening today. We showed you, trying to get you to think about how to explore X and Y. Desmos has a matrix feature. Like I said, it doesn't save the day, but it does help you, and you're allowed to use it, or else I wouldn't have showed it to you. And what you're getting now is what's traditionally called the matrix thinker assignment, which is supposed to do just what it said. It's supposed to make you think about matrices.